So in this video, I'm going to be teaching you guys the compound angle formulae. And this is this is one of the most fundamental and important concepts in trigonometry. So I hope you guys understand what this is and how to use and what it's used for at the end of this video. So let's start. So for what angles can we easily find the exact sine, cosine, and tangent values of? Well, it's the angles on the unit circle, like 30 degrees and 45 degrees and 120 degrees. So we can easily find the sine of 30 degrees or the cosine of 45 degrees or the tangent of 120 degrees. 120 degrees. Yeah. But what about the sine of 75 degrees or the cosine of 15 degrees or the tangent of 105 degrees? How do we find the exact values of these values? Well, we have to use these formulas. And so, but how are we going to use these formulas to find these values? Well, let's try it out. So let's first, as an example, let's try finding the sine of 75 degrees. The sine of 75 degrees using the first equation, this one. So here, sine of 75 degrees must be expressed in the form of sine of x plus y. So 75 degrees must be expressed as the sum of two angles x and y. And this, according to this equation, this value is expressed using the sine and cosine values of x and y. So x and y need to be angles such that we already know the exact sine and cosine values of them. So x and y need to be angles in the unit circle so that we already know their exact sine and cosine values. So 75 degrees must be expressed as the sum of two angles in the unit circle. So 75 degrees must be expressed as the sum of two angles in the unit circle. And in this case, we can express it as 30 degrees plus 45 degrees. Whoop. There we go. So 30 degrees and 45 degrees are two angles on the unit circle. And yeah, 75 degrees here is expressed as the sum of two angles on the unit circle. There you go. And we're going to use this fact and this equation to find this exact value. So the sine of 75 degrees can be written as the sine of 30 degrees plus 45 degrees. There we go. And using this equation, let's just put 30 as x and 45 as y. And we just plug in these values here to do it. So this is equal to the sine of x, which is the sine of 30. So the sine of 30 degrees times the cosine of y, which is cosine of 45, plus the cosine of x, which is the cosine of 30 degrees, times the sine of y, which is sine of 45, which is so sine of 45. Whew, that was pretty fast. And we can put in our sine and cosine values that we already know. So sine of 30 is a half. Cosine of 45 is root 2 over 2. And then cosine of 30 degrees is root 3 over 2, right? And sine of 45 degrees is root 2 over 2. And this simplifies to root 2 plus root 6 over 4. And there we have our answer. We got the exact value of sine of 75 degrees, where 75 degrees is not on the unit circle. So that's pretty interesting. These formulas seem to be pretty useful in finding sine, cosine, and tangent values of certain angles that are not on the unit circle. So we kind of got a rough idea. We put 75 degrees as the sum of two angles in the unit circle, and then used the sine and cosine values of those angles to find the sine to find the sine of 75 degrees. Coolio. So we're kind of getting an idea, but to have a clearer understanding, let's try another example using cosine to find the cosine of 15 degrees using this formula. So I recommend you to pause this video and try it out for yourself first. So find the exact value of this using this equation. And you're back. So let's erase this first to get more space. And then, so we're using this equation, right? So cosine of 15 degrees must be expressed in the form cosine of x minus y. So 15 degrees must be expressed as the difference of two angles x and y. And this cosine value is going to be expressed using the cosine and sine values of x and y. So x and y need to be angles on the unit circle so that we already know their exact cosine and sine values. So same thing as before. We're making sure that x and y are angles on the unit circles because we want the sine and cosine values of them to be exact values that we already know. So 15 degrees must be expressed as the difference of two angles on the unit circle. So 15 degrees must be it can be written as the difference of two angles in the unit circle. So it can be 60 degrees minus 45 degrees or 315 degrees minus 300 degrees. Like, it doesn't matter, but here I'm going to just do it as 45 degrees minus 30 degrees. Oh no, 30 degrees. So here we have 15 degrees as the difference of two angles in the unit circle. Coolio. So let's use this equation then. Let's say this. So let's start. So cosine of 15 degrees can be written as the cosine of let's plug that in. 45 degrees minus 30 degrees. A lot of color changing. So here 45 is going to be x and 30 degrees is going to be y. And we're going to plug in these values and plug in our cosine and sine values that we already know and find the exact value of cosine of 15 degrees. So this will be equal to, according to the equation, this will be equal to cosine of x, which is cosine of 45 degrees, times the cosine of y, which is the cosine of 30 degrees. Cosine of 30 degrees plus the sine of x, which is the sine of 45, and times the sine of y, which is the sine of 30. We got it. And now we just have to plug in those cosine and sine values that we already know from the unit circle. So cosine of 45 degrees is equal to root 2 over 2. Cosine of 30 degrees is equal to root 3 over 2. Sine of 45 degrees is root 2 over 2. And that will be a half. So, and this leads us to square root of 2 plus square root of 6 over 4. Nice. So here we got the exact value of the cosine of 15 degrees by putting 15 degrees as the difference of two angles in the unit circle, and then using this equation to use these cosine and sine values of these angles to find the exact value of the cosine of 15 degrees. So, what do we notice from here? And so let's take a look at these equations and then have a little think about it. So here, if we see that an angle, if we're trying to find the sine, cosine, and tangent value of a certain angle, and we see that we can express that angle as the sum or difference of two angles in the unit circle, or just any two angles that we already know the exact sine, cosine, and tangent values of, then, well, we can use these formulas. We can use these formulas to use the sine to use the sine or cosine or tangent values of those two angles to find the exact sine, cosine, and tangent values of that angle we're dealing with. So here, for example, we didn't really practice with these equations yet, but we can see here that if we want to find the tangent of a certain angle, and we see that that angle can be expressed as the sum or difference of two angles in the unit circle, we can use sum or difference of two angles that we already know the tangent values of. And we can see here that the tangent of the angle we're dealing with can be found using the tangent values of those two angles. So we have to have that our angle as the sum or difference of two angles that for which we already know the exact tangent values of. So yeah, that's why the compound angle formulae is the compound angle formulae is pretty useful, and it's one of the most basic ideas in trigonometry. So I hope you guys got a clear understanding of what this is and what it's used for from this video. And yeah, in the next video we're gonna be exploring the double angle formulae, which will include the compound angle formulae. So yeah, hope you guys enjoyed this video and learned a lot, and yeah, see you in the next video.